Now I will describe an example that we'll use as we talk through the rest of the missing data strategies. This is fake data. And so the x-axis in the graphic and the data set I made up is age. And you can imagine the y-axis is some measure of education. I had in the back of my mind here that this would be years of education, but really it doesn't really matter, right? It's some x variable and some y variable. And if you look at the upper left corner here, you can see what the complete data looks like. And I just made up these values, but suppose it says the complete data set, no missingness. Each person in the data set answered a question about age and also answered a question about education, and there's the picture. Okay, that's the complete data. And then what I did is I simulated removing values from this data set. In other words, creating NA values according to each of the different types of missing data that we have described. And when I remove missing values, I assumed that it was the education value that was sometimes left blank. So I'm assuming that every person in the data set answered a question about age, but perhaps some of them did not answer the question about education. So if you look at the top right picture, it's labeled MCAR, missing completely at random. Remember that missing completely at random is the missing data scenario where we've dropped some of them in a puddle randomly. Which values are missing has nothing to do with which values, what those values would be, right? There's nothing special about any particular data point that tells us whether it's going to be missing or not. So if you compare the missing completely at random graphic to the complete graphic, you can see there's no systematic difference. It's just that there are fewer data points in missing completely at random because the missing completely at random data has some of the education values randomly chosen and then removed. And when we assume someone's education value wasn't observed, then we're not plotting it because having age alone is not enough to put a point on this picture. So again, missing completely at random has the same pattern as the complete data, just as there's fewer data points. Okay, but then I did it again, going back to the complete data. Let me try again to pick some people to have missing education values, this time according to a missing at random strategy. So now I'm going to create the graphic in the bottom left. How did I do this? What I did here is I set it up so that the probability that education would be missing was higher for people who are older. And you can make up different ways that this might be true, right? Maybe people who are older are busy at their jobs and didn't have time to fill out the whole survey, right? Or, you know, suppose this were a different age scale, and those were really elderly people on the top. Maybe you had to be good at using an online survey and click to the next page to see the question about education. The older people couldn't figure it out, right? There's various ways to tell a story such that it's more likely that the older people will be missing the education value. So that's why I have this set up. So if you look at this, for the people in particular who are above like 23 or so, right, it's very likely their education value is missing. Compare this graphic to this one, right? Whereas for the younger people, it is less likely that education will be missing. In this case, whether education is missing is related to age. And because age and education are missing, it's also related to the education value itself. Right? Like if I tell you, oh, I'm thinking of a person whose education value is missing, you know that was a more educated person, probably, right? Because these people in this range where my mouse is are the ones whose values are missing. Now I'm going to go back to complete data again and think about how to use a strategy that will get us to the graphic in the bottom right, missing not at random. So this time I'm going to make a decision about whether values are going to be missing in a way that depends on the education variable only, right? So in contrast, for missing at random, I said, hey, the older you are, the higher the chance education will be missing. But this time, I'm going to write the code so that the age is not what's determining whether education is missing, but only education itself. In particular, what I did was set a cutoff of 13. Okay, so imagine I'm drawing a line right here with my mouse across the complete data. If your education value was higher than 13, then imagine just it wasn't reported, right? You can imagine it's something like there's some kind of survey and the form was set up so you could not actually stick in a value above 13. It wasn't actually possible. It wasn't one of the choices, right? In the multiple choice survey or something like that. So anybody with education older than 13 just could not get their value in, right? Or it could be that if your education value is 13 or higher, that if you're thinking of this as number of years of education, those are the people in college, right? Maybe with a college, well, let's say it the other way. Maybe you could only actually access this part of the survey if you had a high school or elementary school email address login, right? And so anybody who had already graduated from high school couldn't actually answer this part of the question. And so therefore we don't have any values for anybody with education 13 or higher. That's missing not at random, because whether a value is missing depends on the education value itself in a way that we're not going to be able to make up for just by looking at the age value. So it's important to contrast the bottom left with the bottom right. In the bottom left, if you condition on age, if I say, okay, I'm only going to consider people who are between ages 25 and 30, among people who are between 25 and 30, it's just random which of them are missing education values, right? Among people who are between age, I don't know, 23 and 25, it's just random which people are missing education values. Conditional on age, we're just sticking our hand in a bucket and drawing a few people out to be missing, right? So we can condition on age, as we'll see, and try to fill these values back in. But for missing not at random, you can't use age in the same way, right? So we look at the people between 25 and 30, the fact that this one person's education value is not missing is not random. It's because that person's value was less than 13. So when we have missing not at random, it's not going to be possible to look at some other variable that's been observed to help us figure out the missing values. This graphic is just a box plot of education. So the previous slide had scatter plots of education and age. Here we're focusing on education only. So we've got a box plot of the complete data, a box plot of the data with missing completely at random, and the box plot's not exactly the same, but it shouldn't be systematically different either, right? Because this should just be a random subset of the education values. For missing at random, it's slight, but notice that the median did go down a little bit. So if you go back to here, remember that we're missing some of these higher education people. So here, the median's a little lower, right? The third quartile is a little lower. In general, again, this box should be a little lower than this one, but the data set's not that big, so it's not stark. But for this one, right, the box plot of education looks very different from missing not at random, because we've literally made the rule that education can never be higher than 13 in this missing not at random data set. Okay, so the mean of education will be affected if we were to just drop all the missing values. In other words, if we ignore the fact that some of the values are missing and just analyze the data we have, we will get a very wrong answer if we look at the missing not at random data, and a slightly wrong answer with the missing at random data. With this particular data set, it looks like randomly the mean for missing completely at random is higher. But that's just random noise, right? So in general, we'll see with missing completely at random, it's just, we're actually expecting the mean distribution to be similar to this one. So those are the means, right? Again, you'll get the mean pretty much correct if it's missing completely at random. It should be a little off if it's missing at random, possibly a lot off. Missing not at random, it may be very off. What about the variance of these distributions? So we're kind of looking at the width of the box plot. Here's the width of the box plot, width of the box for complete data. For missing completely at random, it's very similar. It's a little narrower for missing at random in this case. We might expect to see something different for missing at random. And for missing not at random, the variance is narrower, it's smaller, right? Well, there's less variance because you've gotten rid of the higher education values. So what we're pointing out here is that it's not just the mean of education, but also the variance that is affected if you ignore the fact that you have some missing values.